Number 28. A 2,000 kg car under state arrest is accelerated along a horizontal roadway at 3 meters per second squared. What is the average power required to bring the car to a final speed of 20 meters per second? So, power, in this one, we're going to use force times velocity. Now, this velocity, you might ask, it's changing, right? But it actually wants to know the average power here, which means force is constant. So we actually need the average velocity. Okay? So this is going to be equal to, well, force is pretty easy because force is just equal to ma times. Now we need to find the average velocity. Well, I start at 0, I go to 20, so can I find the average of those two numbers? Right, that's just 10. Okay? So then I just do m, which is 2,000, times a, which is 3, times 10, which equals 60,000. So the correct answer is E. This one is a little tricky, but the thing you really need to pay attention to here is that we have this average power. Because we're looking for an average power, I would also want to use an average velocity. Okay? Now we could be thinking, okay, well, power equals work divided by time. The problem is that in this scenario, we would actually need to be doing like a derivative, okay? But we don't want to do a derivative because it says average power, okay? Because the work and the time are not necessarily the same because it's moving greater distances over the end period than it is at the beginning period, okay? So in theory, you'd be doing something like this, okay? Normally you have like sort of these deltas here, and then the calculus version would be making it smaller increments, but this would only give us the power over at a specific moment in time. Okay, since it's asking for average power, I need to find an average answer, right? And so in this case, I would want to use my average velocity. So remember, the reason I can't do this, okay, is because the work changes in relationship to time, right? Because it's getting faster, faster, faster. So the distance it moves every second is going to change, right? The only way I can evaluate it is by looking at this and then finding my average velocity. And the correct answer is E.